title here is called Graphing Using Intercepts. Now, we've only focused on a y-intercept, right? Because that's part of slope-intercept form. The intercept of slope-intercept stands for the y-intercept. But there also exists an x-intercept. Right? There's two axes, so there's two intercepts. So another way of graphing, which can be easier, faster, or longer or slower, depending on how the equation is written, is graphing by intercepts, meaning you find only the y-intercept and the x-intercept, no slope. So I'm going to give you a different method for graphing, and you'll find out how to use it, when to use it, as you go through your homework and also the Khan Academy tomorrow. Okay, so first, let's just again look at exactly what we're talking about when we talk about intercepts. I'm going to do this on Desmos. So if I look at, let's say, the x-axis. X-axis actually has an equation. It's y equals 0. Right? And I look at any point on that line. Let's see. I call it A 0. Step of 1. There you go. So any point on the x-axis, if you look at this, has what in common? Yeah, they all have a y equals 0. So an x-intercept, by definition, it has a y or domain, range of 0. That's why it's y equals 0. It's one of those that does not change range at all. It stays at 0. So if you want to find an x-intercept, you know that y equals 0. Not terribly difficult, right? So we could go back to here and say, well, if I want to find an x-intercept, not like that. If I want to find an x-intercept, that is where the y equals 0. And I can take my equation and just put in y for 0. Substitute in, 2x plus 0 equals 6. All right? And solve whatever equation's left over. What times 2 is 6. And you get x equals 3. And voila, you have your x-intercept 3, 0 right there. Okay? Not too bad, right? That's to find an x-intercept. Let's do another one, number 2. Again, going off of here, we know an x-intercept has a y value of 0 no matter what. So if we know the x-intercept will be something, 0. That's the thing that doesn't change for an x-intercept, is the y is always 0. So we just say, okay, that's 2x minus 0 equals 6, and you actually get the same equation, which is not exciting, but yeah, 3, 0. So that's how you find an x-intercept. Try number 3. Go ahead and find the x-intercept on number 3. See how that goes. So 2 times what is negative 6, and you get negative 3. Yeah, so we got 1, 2, negative 3 to the left from the origin, instead of to the right. Not too bad. So that's the really new part. We haven't done anything with x-intercepts, but you can see, plug it in 0 and figuring out what x equals, not too bad. And what you're going to do is you're going to do the same thing, but with the y-intercept as well. So I could take this, right, and adapt it for the y-axis, and it's similar. I'll make it count by ones. Right. That one, and in the same way that a x-intercept is, the y-intercept always has an x value of 0. So it's kind of like the opposite, right? The x-axis always has a y of 0 right here, and the y-axis always has an x of 0. So it's kind of like the 2 points that have the zeros, more or less. Those are intercepts by definition. If there's a 0 in the coordinate, it's an intercept. You just have to keep in mind which is which. Right? So we can go through and find the y-intercept as well. Very similar, except that for the y-intercept, the x is 0. So you put a 0 in for the x. Right, so we got 2 times 0 plus y equals 6, and 2 times 0 is just 0, right? So this is not too exciting, it's just y equals 6, right? So we have a y-intercept of 6. 1, 2, 3, 4, 5, 6. And you have 2 points, so now you can use a straight edge and graph it. And of course, if you were to do what you did on last night's homework, how would you solve this? If this is last night's homework, you would have just subtracted 2x on both sides, right? And you would have got y equals negative 2x plus 6. And what do you know? The y-intercept here matches the y-intercept here. It's the same number. You're graphing the same line just in a different way, so it better be the same number, right? And then here you have a slope which is negative 2 over 1, and if sure enough, if you start at positive 6 and you go down 2 over 1, yeah, you eventually, you get the exact same line no matter what. So we're showing you another way of doing the same thing. You will come across circumstances, though, where one is definitely easier than the other. That's why we're showing you both. So we definitely want to know how to use intercepts because it'll be a lot easier for some of the equations you'll be given. But something like this, either way, it's kind of like the same. But this is what you call a check. If you know how to graph it one way, using intercepts, then you can graph it the other way using slope-intercept, and you make sure you get the same line. Okay. So let's do a few more. Let's see here. Once again, which one is 0, x or y here? For y-intercept, which one's going to be 0? Yeah, x is 0. That's the only thing you got to keep in mind is, well, if I'm finding a y-intercept, that means I want to find an answer for y. It should be some number. So that means the other one, the x, is a 0, right? So then you plug it in, 2 times 0 minus y equals 6. So 0 minus what is 6? Right? And you'll get an answer of negative 6. This one is negative 6. 1, 2, 3, 4, 5, 6 down here. And now you have 2 points. You can graph it. You can also find the equation just by finding the slope. Up 6, right 3. 6 over 3 is 2. So that's the equation, y equals 2x, and the y-intercept is minus 6. And if you're to solve this one up here, like you did last night, subtract 2x on both sides, divide both sides by negative 1, you'll get the same thing. So it's all related. You're just doing it a slightly different way. And once you can put them all together and see that, well, they're all kind of doing the same thing in a different way, that means that you have this down. Okay? And of course, use a straight edge to make all that. I'm going to skip down to, for the first front side, we kind of gave you some numbers that are easy and compatible. Like, for instance, both negative 3 and 4 go into 12 evenly. So you'll get some nice whole numbers, but they don't have to be these nice whole numbers. If you flip it over to the back, and let's say, well, 7, 5, and 2 go into 10, but like a number 8. If we look at number 8 closely, we want to find the x-intercept. That's where y is 0, once again. And we want to find the y-intercept. That's where x is 0. That way I can find out an x-intercept, I'm looking for an x value. The y-intercept, I'm looking for a y value. And if you find the x-intercept, okay, that's nothing exciting. X minus y equals -3. Yeah, x equals -3, no big deal. But when you do the y-intercept, right, it's 0, fix that, 0 minus 2y equals -3. So -2 times what equals -3? Alright. Now, all of a sudden, yeah, you have to actually make sure you show the work, divide both sides by -2. It's not always going to be these nice numbers. So -3 over -2 equals 3 over 2. And how do you graph 3 over 2 on a number line? Where is 3 over 2 on a number line? And this is where you go back to the 4th grade and convert this to a decimal. So what's 3 over 2? 3 divided by 2 as a decimal. Or a mixed number. 2 goes into 3 one time with a remainder of 1. So 3 over 2 is the same as 1.5. So you have to go to 1.5, 0, 1.5, which is right here. So not always easy just to get off the graph. That's why we need to solve it algebraically. And we don't always have a graph to figure out what the intercepts are. So we can figure out intercepts without a graph if we need to. And that's exactly what you'll be doing on your assignment when you come in tomorrow on Khan Academy. I just assigned it, but it looks like this. Right? There's no graph there. You just have to know that, well, the y-intercept will have an x of 0. The x-intercept will have a y of 0. Plug in the numbers, solve the equation, and then you can find the intercepts. No graph needed. So that's where you're heading by tomorrow. Today we're going to practice with the graph so you can do it algebraically and see it graphically and see how they're linked. But, you know, you don't really have to have the graph to get those intercepts now. Okay? And fractions and decimals are okay. You will have to go back to elementary school and maybe convert something to a mixed number or a decimal in order to graph it. Okay? So just keep that in mind. 3 over 2, it's expected that you know that that's 1.5 or 1.5. Just type in a calculator if you're not quite sure. Right? 3 divided by 2, 3 over 2, 1.5. Okay? No problem. So I'll let you guys work on that. Note that at the end it's more review. Alright, so you're going to have to start reading the directions carefully. If it says do slope-intercept form, that's what you did last night. If the directions say find the x and y intercepts, that's a different method. So when you get a quiz or your test, make sure you read the directions and you're following what you're supposed to be doing, not just, you know, I'm going to do slope-intercept all the time. Well, you're going to find out really quickly, well, not following directions, that's not a good idea in the first place. And second of all, there's going to be problems that are much easier to graph using intercepts. So if you only know one method, you're causing yourself to do more work in the future because you only know the one way. And you'll figure out by, after doing plenty of these, like, oh, when it's kind of like this, it's easier to graph using intercepts, but if it's like this, it's easier to graph using slope-intercept form. Let's see here. Anything else? I think that's about it. I think the last thing I'd mention, even though I did it on every example, make sure you write a coordinate. So all these should not just be a number, but the actual coordinate, the x and the y. Make sure these are all coordinates, zeros in the right place, of course. All right, good. This is number 29, I believe, yes. So you have this, and then when you come in class tomorrow, I'll be stamping all the homework that hasn't been stamped, and you'll be working up this. And as soon as you finish with the Khan Academy warm-up tomorrow, there'll be a little project to work on, and just review and things like that. Okay? All right. You can spend the rest of the period finishing this up. If you want to, you can already start on this warm-up for tomorrow. I do stress you have to get everything correct 5 times in a row. Show your work, write it down. Don't just stare at it and say this is easy, because then you get to that last one, make a mistake, and you have to start all over. Just write it down, be careful.